So how do we transform a polynomial? That's a great question, and I'm glad you asked. I'm glad you asked because you actually already know the answer. We've transformed polynomials before, and we're going to do it again. So what I want you to do is look at these quadratics, which, remember, hint, quadratics are polynomials. And I want you to describe the transformation of each. So I want you to pause the video and do that. Unpause when you are ready to confirm your answers. Okay, so the first one here, g of x, we have x squared plus 5. So the plus 5 is not in what we call the parent function. Remember, the parent function is x squared. So since this is outside, it's going to go up 5. Here, for number 2, g of x is the quantity x minus 1 squared. So now the minus 1 is inside of the parent function. So this is going to go to the right 1. Number 3, g of x is the quantity x plus 2 squared. Again, the plus 2 is inside of the parent function, so this is going to go left 2. And number 4, g of x is the quantity x minus 5 squared plus 3. So we have two transformations here. Here we're going to go right 5 and up 3. Nice work. Okay, so now let's just move on to higher degree polynomials. So here I have f of x equals x cubed. This is what the graph looks like. You could graph this on your calculator or Desmos as well to verify that. So what we're doing for A, B, C, and D is we want to describe the transformation of g from f, and we want to write a rule. Remember, when we say write a rule, that just means write the equation. So for instance, if I look at A, I would say, okay, well, for the basic parent function, it went through 0, 0. This moved to the right 2. So my description is going to be right 2. Now, how do I write an equation for that? I would say g of x is x minus 2 to the third, because it moved right 2. And the parent function was x to the third. If I look at the next one, here we have a choice. So how would you describe the transformation from f to g? Well, if you visualize, if I took this f and I flip it over the x-axis, I'll end up with g. But also if you took f and you flip it over the y-axis, you would end up with g. So this is one of those ambiguous situations where it could be a reflection over the x-axis, or it could be a reflection over the y-axis. Now, since we don't do a lot with reflections over the y-axis right now, I'm going to say it's a reflection over the x-axis, but either of them would be correct. And if I say it's a reflection over the x-axis, my equation is going to be negative x cubed. Just to point out, if I said reflection over the y-axis, now my equation would be negative x cubed. And because this is to the third, it doesn't matter if the negative is in the parentheses or outside the parentheses. That's why this could be considered a reflection over the x-axis or the y-axis. But this is what we would be looking for in terms of the difference of a reflection in the x-axis or a reflection in the y-axis. Okay. I want you to try and do C and D. So describe the transformation and write the rule. Pause the video. Unpause when you're ready to check. All right, so for C, hopefully you said that this went up 2. And so that's going to be g of x equals x cubed. Whoops. And for D, hopefully you said it went left 2 and down 1. So that's going to be g of x equals the quantity x plus 2 cubed and then minus 1. Notice what I'm looking for to determine the transformation is I'm looking for, so from 0, 0, where is that kind of middle of the turn? Or I guess I would call this like a double turn, right? Where it's like kind of, if I'm visualize, I'm going to turn right and then I turn left. And so where is the middle of that? And so here I can see, well, that point went from 0, 0, and it went left 2 and down 1. All right, moving along, we're going to go a little bit quicker here. Same idea here. This is the basic function x to the 4th. So I want you to describe each of these transformations and write a rule for it based on the original function is x to the 4th. So pause the video, try that, unpause when you're ready to check. Okay, so again, just to kind of help you out if you're a little bit confused, what I'm focusing on is where did the parent function go through 0, 0? What did that look like? And notice that x to the 4th looks very similar to a parabola. It's not a parabola, mathematically speaking, but it looks a similar sort of shape, right? Notice that it's kind of like a U, just like a parabola, except for the bottom part's a little bit flatter. That's kind of how we could describe it. So I'm looking for where did this piece move? And here I can see that moved right 2, down 2. So I'm right 2, down 2. So this is going to be g of x equals the quantity, x minus 2 squared. This moves it right 2. And then minus 2, that moves it down 2. Here I have 3 transformations. It went right 2. There was a reflection over the x-axis. That's why it's opening down. And then it went up 2. So right 2, reflect over the x-axis, and then up 2. So this is going to be g of x equals negative quantity, x minus 2 squared, and then plus 2. So the negative is the reflection, the minus 2 is right 2, and the plus 2 is up 2. All right, so here we're going to, given the function and the transform function, now describe the transformation. So pause the video, describe the transformation from f of x to g of x, and pause when you're ready to discuss. Okay, this one went left 5 because of the x plus 5 cubed, and up 2 because of the plus 2 outside of the parent function. So remember, I do want to emphasize the parent function is showing us the general shape of the function. The plus 5 and the plus 2 are just moving that function or that image around. All right, next one, same idea. Parent function is x cubed. Describe the transformation. Unpause when you're ready to check. You're doing great. Okay, so here is left 2, vertical stretch by 4, and down 5. So we haven't seen the vertical stretch that much, but that's that, right? I mean, we've seen that a lot before, but not today. Here was our left 2, and here is our down. Now keep in mind, vertical stretch, in terms of if you were to actually graph this, that is literally taking all of the y coordinates and multiplying them by 4. So that's how that vertical stretch occurs. Okay, so here we're given the function f of x equals x cubed plus x squared plus 1, so it's not a standard parent function. I mean, we still have a parent function, but there's a little bit more going on. It's not just a cubic. I mean, it is a but there's also a squared piece of that and then a constant piece of that, right? So this is a polynomial. So I want you to write a rule for g and describe the graph of g as a transformation of the graph of x, or really just describe the transformation. So let's do A together, and then I want you to try B on your own. So for A, if I have g of x equals f of negative x, this is literally saying to plug in a negative x wherever there's an x, right? Well, what happens here if I square a negative? It goes away, right? Squaring a negative just makes it positive. And here we already saw this earlier, right? I said that writing negative x to the third or writing the negative outside is the same thing. So in this case, g of x is actually going to simplify to this. Now, what about our description though? Well, we have to look back at the original part and what was this transformation actually doing? And remember, if there's a negative inside on the x, we would describe this as reflect over the y-axis. So that is our transformation that is occurring here, although this is the outcome of the polynomial. So we need to understand this notation here, that this is because the negative is inside, that is saying reflect over the y-axis. And just to show you what would be different if it was reflecting over the x-axis, we would have negative f of x. Okay, so if I have some h of x function, this would reflect over the x-axis because now the negative is outside of the parent function. And this is normally how we've seen things. Okay, so I want you to try and do B. Pause the video, unpause when you're ready to discuss. So B is a vertical stretch by 3. I know that because the 3 is outside of the parent function. The parent function is f of x, and it's being multiplied by that. So there's two ways I can write this. The blue would be correct. It is literally saying multiply 3 times the entire function, right? And the entire function is x cubed plus x squared plus 1. Or I can distribute that, and so that's what you see here in the purple. So I get 3x to the third plus 3x squared plus 3. So either the blue or the purple would be correct. All right, so what we hopefully get from today is that polynomial transformations are the same as quadratic transformations. And that is really because a quadratic is a polynomial, but we have focused so much earlier this year on quadratics that hopefully that helps us understand how the transformations of polynomials work.